You know that feeling, right? The throb, the heat, the swelling after an injury. We've all been there. But what if I told you that inflammation isn't just a symptom? It's actually one of the most ancient, most fundamental survival tools your body has. It's a full-on biological battle. And today, we're going to take you right to the front lines to see exactly how it all goes down. And get this, our understanding of this goes way, way back. A Roman writer named Celsus, almost 2,000 years ago, absolutely nailed the four main signs of inflammation: redness, swelling, heat, and pain. It's amazing, right? These are the classic, universal signals that your body has sounded in alarm.
Just think about it for a second. A tiny little splinter, an invading virus, a burn from a hot pan. On the surface, they seem totally different, but inside your body, they all kickstart the exact same emergency protocol. So what is this hidden battle that they all have in common? Well, the answer is a process that's both crucial for keeping us alive and, you'll see, surprisingly complex.
Okay, so first things first, let's get one major misconception out of the way. We tend to think of inflammation as the problem, the disease itself. But it's not. It's the response. It's your body's carefully coordinated effort to fight back against a threat.
At its core, inflammation is a protective response. Its entire job is to get your body's defense forces, we're talking about specific cells and proteins from your blood, to the exact spot where there's an injury or an infection so they can eliminate the problem. Honestly, without it, even a small infection could run wild, and wounds would simply never heal. It's that essential.
The whole process can actually be broken down into 5 key stages, which some people call the 5 R's. It's a great way to think about it. First, your body has to recognize that there's an enemy. Then, it recruits its cellular soldiers. These soldiers then get to work to remove the threat. The whole thing is then regulated to make sure it doesn't spiral out of control. And finally, if all goes well, the process ends with resolution, which is basically repairing the damage.
So, what pulls the trigger on this whole chain reaction? Well, a whole bunch of things. The most obvious ones are infections, from bacteria or viruses. But it can also be triggered by tissue death, say if an area isn't getting enough blood. Even physical things like a splinter or some dirt can do it. And then, sometimes, the system just misfires and launches an attack against something harmless, like an allergies, or even against your own body, which is what happens in autoimmune diseases.
So, the alarm has been tripped. What happens next? Well, the very first moves in this battle are all about changing the battlefield itself, and that means we have to look at your circulatory system.
The two main players in this initial, rapid response are your blood vessels and your white blood cells, which are also known as leukocytes. You can think of the blood vessels as the highways and the leukocytes as the emergency vehicles of your body's defense system.
So the first thing that happens is that the blood vessels in the affected area dilate. They get wider. This ramps up blood flow, and that's why an inflamed area gets hot and looks red. At the very same time, the walls of these vessels get leaky. They become more permeable, creating little gaps for reinforcements to squeeze through. Now, this table points out a really key difference. The fluid that leaks out during inflammation is called an exudate. And as you can see, it's packed with proteins and cellular junk. It's the real deal. This is totally different from something called a transudate, which is mostly just water and is caused by simple pressure changes, not an active, raging inflammatory battle.
Okay, so the gates are now open. It's time to get the troops from the highways of the bloodstream out to the actual battlefield in the tissue. This is the story of the leukocytes' incredible journey.
See, normally, inside your blood vessels, these leukocytes are just kind of tumbling along with the flow of blood. But when an alarm goes off in a nearby tissue, they have to pull off this amazing maneuver. They have to stop, stick to the vessel wall, and then squeeze their way out.
And this slide shows you the 3 main steps. First, you see them rolling along the vessel wall, kind of bouncing along. Then, chemical signals flare up and cause them to adhere firmly. It's like they're slamming on the brakes. And finally, the last step, they migrate, actually squeezing themselves through the gaps between cells to get into the tissue. It's pretty incredible stuff. So once they're out, how on earth do they know where to go? They follow a chemical trail. The process is called chemotaxis, and it's basically a molecular GPS. The concentration of these chemicals gets stronger and stronger the closer they get to the injury, guiding them right to the target.
But not all the soldiers arrive at the same time. This chart shows the timeline pretty clearly. The first wave, the shock troops that get there within hours, are called neutrophils. Then they're followed by a second, larger wave of cells called monocytes.
These guys arrive a little later and transform into macrophages, who are basically the heavy-duty cleanup crew.
All right, the troops have arrived. Their mission is simple, but it's brutal. Find the enemy and eliminate it. This is where the real dirty work begins.
Their number one weapon is a process called phagocytosis, which literally means cell eating. It's a three-step mission. First, they have to recognize and latch on to the target, whether it's a bacterium or just dead cell debris. Then, they engulf it, pulling it completely inside themselves. And finally, they unleash a powerful internal arsenal to utterly destroy it.
And that arsenal is no joke. I mean, they use things called reactive oxygen species, which are basically the same active ingredients you'd find in bleach to just obliterate microbes. They also use nitric oxide and a whole cocktail of powerful enzymes to break down anything they've swallowed. These cells are literally designed to be ruthless, efficient killing machines.
But here's the catch, and it's a big one. These weapons are so powerful that if the battle gets really intense, they can actually leak out and start causing collateral damage to your own healthy tissues nearby. And this is that crucial tipping point where inflammation can start to harm the very body it's supposed to be protecting.
And that brings us, of course, to the dark side of inflammation. What happens when this protective response doesn't switch off when it's supposed to? Or what if it's aimed at the wrong target entirely?
This slide perfectly contrasts the two faces of inflammation. On one side, you have acute inflammation. That's the short, sharp, intense battle we've mostly been talking about. It starts fast, features those neutrophils we mentioned, and usually resolves. But on the other side, you have chronic inflammation. This is a slow, smoldering war that can go on for a long time. It's dominated by different cells like macrophages and lymphocytes, and it often leads to severe, progressive damage to your tissues.
So why does it become chronic? Well, sometimes it's because the body just can't get rid of the invader, like the bacteria that causes tuberculosis. Other times, it's because of those autoimmune diseases we talked about, like rheumatoid arthritis, where the body is just constantly attacking itself. Or it can be from long-term exposure to things that just keep irritating the body, like silica dust or cholesterol crystals.
So ultimately, any one of these acute inflammatory events really has one of three possible endings. The best-case scenario is complete resolution. Everything goes back to normal, good as new. If the damage was too severe, the area might heal with a scar, which is a process called fibrosis. And the worst case, the battle never ends, and it transitions into that dangerous, damaging state of chronic inflammation.
So as you can see, inflammation is this brilliant, life-saving defense system, but it's also a true double-edged sword. And that really leaves us with a final crucial question to think about. What happens when your body's best defender becomes the enemy within?